Welcome to Direct Current Deep Dive, exploring the technical framework of Current OS. A MOOC designed to dive into the principles behind Current OS technical decisions and their role in defining the standard for direct current electrical systems, also commonly referred to as DC-coupled systems, or DC microgrids. This video is part 5 of a 6-part series. Explore the remaining videos on the Current OS YouTube channel to continue learning about the world of direct current. In this video, we'll explain the underlying principles that drive Current OS's technical choices on pre-charging. In direct current systems, capacitors are everywhere. This creates a significant challenge. At startup, they generate very high inrush currents. It gets even more critical. An empty capacitor essentially acts as a short circuit. Without proper management, this could trigger all the protections the moment the system powers on. To avoid this, every DC device must include a pre-charging system. This concept might seem exotic to those accustomed to alternating current systems, but pre-charging is a standard practice in DC systems. For example, all electric vehicles with DC chargers already have built-in pre-charging systems. Companies like Texas Instruments have even developed dedicated chips to control pre-charging. Managing the pre-charge of capacitors in DC systems is a well-established process for ensuring smooth operation in DC installations. Current OS has defined a specific startup sequence for DC systems. The system starts, reaches U1, the initial voltage level, where sources start contributing to bring the system up to U2, the lower end of the nominal voltage band. At this point, a brief pause is implemented before allowing loads to draw current within specific limits of time and amperage. After this, loads return to a standby state, allowing processors and the broader system to initialize. Next, the system transitions into full operation, permitting current and power demands to increase progressively. This startup sequence, beginning with the black start phase, moving through pre-charging and energizing and finally activating loads, has been codified within Current OS standards. It ensures that products from various manufacturers can function harmoniously without tripping circuit breakers upon connection. This is for general-purpose LV-DC systems. Each piece of equipment includes its own pre-charging function. This maximizes interoperability between products from different manufacturers and simplifies maintenance. Any device can be disconnected, replaced, or reconnected independently without affecting the rest of the installation. In the case of specialized LV-DC systems, for example data centers or dedicated industrial process islands, other approaches exist. For example, a single centralized pre-charger may be used for an entire circuit. However, this approach requires every device connected to that circuit to be fully known and carefully coordinated. Future modifications or expansions are therefore very limited. Maintenance also becomes more complex. Because all equipment depends on the same pre-charger, the entire group of loads generally needs to be disconnected or shut down simultaneously. For these reasons, centralized pre-charging is typically reserved for very specific applications, where the equipment configuration is fixed and changes are expected to be rare. Both pre-charging approaches are well established and standard in the realm of DC systems, providing a reliable foundation for consistent performance across installations. This concludes the pre-charging presentation of Current OS. Want to learn more? Check out the other 5 Current OS MOOC videos covering an introduction to Current OS, voltage bands, power management, electrical protection, and earthing, or grounding. Thank you for watching. See you in the next video.